we've shown you lots of pieces for how you start building classes. Let's look at an example to try and bring a lot of this together. And I'm going to use a fairly simple example. I want to create a set of integers. So a set's just an unordered collection of objects. It has the property that each particular instance is only present once in a set. And we can do things like taking the union of two sets or the intersection of two sets or adding things to two sets. So let's think about what we would like. We want to create a new type to represent a set or a collection of these integers. So we're going to have to give some definitions of what we expect to have. And initially we're going to assume that the set is empty. Now that's going to help us think about our definition of how to initialize something. Set's initially empty. Great. Second characteristic we're going to have, as we said, is that a particular integer should appear only once in the set. This is a constraint on the set. It's often called a representational invariant, right there. And it's going to be enforced by the code in the methods of the class definition itself. And I'm going to actually have some options in terms of how I want to do things. For example, if I have a particular integer in the set and I try and add another instance of the same integer into the set, what should happen? Well, I could throw an error, or I could say, you know what, nothing happens, I just can't put it in. I'm going to have some choices in terms of how I do it. But notice what I'm doing here. I'm defining the behavior of a set. Initially empty, a particular integer appears in it only once. Okay? What else do I want here? Well, I need to have a decision, since I'm defining the class, of what is the internal data representation. The user's never going to know about this. It's going to be hidden from them. I want the behaviors to be visible to the user. I still need to define the internal data representation. And so I'm, in this case, going to be really simple. I'm just going to use a list as a way to remember the elements of a set. It's going to be really easy in terms of how I'm going to actually build all of this. That sounds great. Okay, so I'm going to use a list to represent the elements of the set. What else do I need? I've got a definition of the behavior. I've got the internal representation. Oh yeah, what's my interface? I need to describe what the user is going to have access in order to be able to do things to a set. And I'm going to create a very simple interface here. It's going to have just 2 or 3 portions to it. First thing is I need to be able to put integers into the set. I'm going to call that method insert. It's going to take an integer e as an argument and insert it into the set so long as it's not already there. And notice, if I do this twice, then I have to worry about that. So my implementation of insert needs to make a decision about what to do if the element's already present. So insert is one of the behaviors I want. Second thing I'd like to know as well is something there. And I'll call that member. So member will take an integer e, and for an instance of a set, it will return true if e is in the set. It will return false otherwise. And I'd like to finally, of course, be able to take things out. I'd like to be able to remove things from the set. Okay? And so I'd like to say, given an integer e, let me take it out of the set. And here I also have a choice, because what if I try to take something out of the set that isn't there to start with? Well, here my choice is I could either say that's an error, or I could decide, you know what, if I try and do it and it's not there, I'm not even going to worry about it. I'm going to opt for this version to say that this is an error if you try and do it. But again, my definition of my class, my choice as to what I'd like to have there. All right, good. What have we got here? Got a definition of the behavior, its initial state, any other constraints on what it should do. We've got a decision on the internal data representation. And we've got an outline of what we'd like the interface to that object look like. So now we can move on. And let's build it. I'm going to walk through this code, and then I'm going to show you an actual example of it. So I'm defining a class. I'm going to give it the name intSet. It's a set of integers. Again, I need to know what it inherits from, and it's just going to be object. There's nothing special here, so it gets the basic methods of any object within Python. I've got a little specification for it. It says an intSet's a set of integers. The value is represented by a list of ints. We're going to call that list self.vals, just so we know what it is. And every int in the set occurs in that internal representation exactly once. What else do I need? Well, I need an init. Remember what I said my behavior was. I said it's going to initially be empty. So init here is very simple. When I call intSet and it creates an instance, I'm going to call init on it. And I want this to be something that simply creates an empty list. There it is. It's going to bind in the instance the name vals to an empty list. And then, of course, that instantiation will just return that frame as the overall instance. What else did I say I needed? I said I needed an insert method. Okay, I can do that. Insert is pretty simple. It says if I'm going to insert the integer e into my list, into my set, Here's what I want to do. I first want to make sure it's not already in there. And I can do that by simply saying check to see if E is in self.vals. If E is not in the list, then I'll put it in. And I'll simply append it to the end of the list. And notice what this does. It says take self, which points to a frame. Inside there, get the binding for vals, which we created up here, which points to a list. And then append to that list the element E. Notice I'm also making a decision here, which is if E is already in the list, I'm not throwing an error, but I'm simply not inserting it in. So I've already built in that constraint, if you like. What else might I like here? Well, I want to be able to do things like print out some reasonable version of what the list or the set looks like. So I'm going to do the following rather interesting thing here, and I'm going to talk about it a little bit more in a second. But basically what I'm going to do is, given self.vals, which is a list, I'm going to sort it. And notice the open paren, because it's a procedure. That will take vals and sort it and restore that away as the binding for vals. And then I'm going to return a representation that has a curly brace at the beginning, a curly brace at the end, and I basically just want all of the values separated out by commas. So I'm going to use one of those little list calls here, which is for each element in self.vals, I'm going to return the string version of that, just convert it into a string. That's going to give me a list of strings. And then under the comma, I'm going to use the join operation to grow this together to create, in fact, just a set of those elements represented in a particular way. Let's actually look at this before we look at some of the other code, just looking at inserts and prints. So I've got the code over here on my computer, and I'm going to load it up into an environment. So let's look at some examples here. So I need to create an int set, so I'm going to do S is an int set. Notice there's the open paren, and it says I just need no arguments here, so it's going to return an empty set. So there it is. And if I print the value of S, I just get open close curly brace. There's nothing there. Okay, I want to put something into S, so I do s.insert. Oh yeah, S says here's an object. The dot says get the insert method associated with this object, and it does it by saying S points to a frame. In that frame, look out the definition for insert that I bound in there. So there's s.insert, and it says just give me an integer. So I don't know, we'll give it 3. There we go. Let's put another thing in there. Oops, I didn't mean to hit cap lock there, so let's do this properly. S.insert 4. Oh, and let's try and put 3 in there again. And let's look at what S now looks like. And there's that representation. And notice, even though I tried to put 3 in there twice, it didn't happen. So it just says I got 3 and 4 inside of my set. Great. We're off to a good start. What else would we like to have? Well, we said we had some other things we needed here. So other procedural attributes. I need member. I need something that tells me if an element is there or not. That's also pretty easy to do. Again, member is going to be called on self, which is the instance, with an integer E. And what's it say? It says look in self.vals. So you take self, which is an instance, you look up vals, which is that list, and then you basically say if E is in that list, that will be true, and I'm going to return that value. If E is not in that list, it'll be false, and I'm going to return that value. So if I go back over to my code here, I could say sorry about that, let's do this, s.member. It says give me a value, so is 3 in there? You bet. S.member is 5 in there? No, it's not. And notice what it's doing, it's just going inside, pulling out the particular instance variable for vals, which is a list, checking to see what's there. What else do I need? Well, I've got to be able to remove an element. And here's where I'm going to think carefully about what I'd like to have happen. Right? Because I made a choice. I said I want it to be an error if you try and return something that's not there. So here's my remove definition. Okay? And it says, oh, there's that try format. It says, try and remove E from self.vals. And this may look a little funky, so let's be careful here. Self points to an instance, a frame. Inside of there, we get the binding for vals, which is a list. So this is a list. And the dot says use the remove method for lists. So lists actually come with a remove method. So it's not referring to this, it's referring to the type of this argument, which is a list, and that's giving me a remove method. And what that does is it goes through the list and removes the element E and returns a new list with that element removed. And that will be rebound to vals. So it would take it out. That's great as long as E is there. If it's not, then try is going to throw an error. It's going to raise an exception. And in fact, try says, do this. But if there is an error, then in that case, go to the except clause and raise an exception. Now, I could have let the error just flow through, but it's much nicer to, in fact, say, gee, raise will return a value error that prints out that this element was not found. And that's going to actually help me in thinking about where's the flaw in my thinking or where's the bug in my code. So let's go back over here and let's do one more. Let's insert 6 into here just to add a little bit more. Again, I can print out what S looks like, and I got 3, 4, 6. Okay, so I'm now going to remove 3 from S. And the clause often does something, and we know what it should have done. It should have taken S, looked it up, that's an instance, look up the binding for vals in that frame, that's a list, and use the list remove method to remove 3 from the list and rebind that new thing out. And in fact, if I now do a print of S, wonderful, 3 is gone. And if I lose my memory, which I often do, and I try and remove 3 again, aha, it actually does now throw an error. Oops, sorry, I typed the wrong thing. Let me redo that. I said S remove 3, not remover of 3. And that's better, because notice what it has done. It has raised a value error that says, I wasn't able to find that particular object 3 inside of this list. So there you go. You now have an example of building a class. And notice what I've done. I decided what's the overall behavior, what should it look like when it starts. I said what's the internal representation I'm going to use, and then what are the interfaces. And with those interfaces, notice when I was typing on my computer, at no point did I ever explicitly reach down into the list and try and manipulate it. I could have done that if I wanted to, and in fact, if I go back over to my computer, I could ask what's the value of s.vals, and there's the list. That's because I can in Python reach in and get it, but I never did that. I always used the defined interfaces, and that's what you should do as well. And in the next lecture, we're going to build on this to start looking at how we can build more interesting classes of objects.